So for the problem, we have a 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliter solution of calcium hydroxide with 0.157 molarity. And you have to find the concentration of the hydrochloric acid in the original solution. So we should start off by drawing pictures, and you have the hydrochloric acid with a volume of 75 milliliters, but since it has to be in liters, we know that it is 0.075 liters. And we do not know the molarity of the hydrochloric acid. But we have the calcium hydroxide, and the volume is equal to 27.3 milliliters, which we know is 0.0273 liters, and we do know the molarity, which is 0.157 moles per liter. And in the final solution picture, we can see that the hydrochloric acid completely disassociates into a hydrogen ion and a chloride ion. And you have a calcium hydroxide, which breaks apart into a calcium ion and a hydroxide ion. Now, in titration, your goal is to lower the hydrogen ion and hydroxide ion concentration. And to do this, you would need to add another hydrochloric acid, which are written PEN. And the new hydrochloric acid breaks apart into ions. Now, in the particle picture, you can see that there are two hydrogen ions and two hydroxide ions, which come together to form two molecules of water. This whole process of making the second water neutralizes the solution, and we reach the equivalence point. And from the particle picture, we can find the products of the reaction, which are two molecules of water, one calcium ion, and two chloride ions, which come together to form calcium chloride. And this is the balanced equation, and it's 2 HCl plus CaOH2 yields CaCl2 plus 2H2O. Now, we know that we are given the volume of the hydrochloric acid, which is 0.075 liters, and we don't know the molarity and we don't know the moles. But for the calcium hydroxide, we're given the volume, which is 0.0273 liters, and the molarity is 0.157, and we do not know the moles. And since we know that concentration is equal to moles over volume, and we know the volume and molarity of the calcium hydroxide, we can figure out the moles of calcium hydroxide. So concentration is equal to moles over volume, and moles is equal to concentration times volume. The molarity of the calcium hydroxide is equal to 0.175 times 0.0273 liters, which is equal to 0.004261 moles of calcium hydroxide. But since we need significant figures, specifically 3 significant figures, we know the answer is 0.00427 moles of calcium hydroxide. And since we know the moles of calcium hydroxide, we can use the stoichiometry from the balanced chemical equation to transfer that to moles of hydrochloric acid. And since we know from the particle picture and the balanced chemical equation that for every mole of calcium hydroxide, there's 2 moles of hydrochloric acid. So when we put that into moles of hydrochloric acid, we get 0.00854 moles of hydrochloric acid. And now, since we have the volume and the moles of the hydrochloric acid, we can figure out the concentration of the hydrochloric acid of the original solution. And so we have 0.00854 moles divided by 0.075 liters. That is equal to 0.113866667 moles per liter, and it has to be at 2 significant figures, so it's 0.11 m. And now we know that the concentration of HCl in the original solution is 0.11 moles per liter. Now, a common mistake for this problem would be that one would use M1 V1 is equal to M2 V2 and figuring out how many moles of HCl are equal to that many moles of calcium hydroxide, instead of using the balanced stoichiometry, the stoichiometry from the balanced equation.